Okay, hello everyone. Welcome to this spatial spotlight session. My name is Lucia and I'm a data scientist here at Capto. And today I'll be showing you how to measure merchants' performance in CPG using spatial scores. So let me first share my screen here. Okay, so that we can start with the session. So the idea for the session of today is that we will imagine that we are a CPG company that sells a specific product, that it's a beverage product, for example, in different bars and restaurants, and we want to know whether the points of sales through which we are selling our specific product are performing as expected, or if they are selling above or below expectations. That means whether they are overperforming or if they are underperforming. For these types of analysis, it is very important to define a business criteria because the analysis is based on this specific business criteria. If we change the criteria, the results of the analysis will change. So in this case, the business knowledge, what it needs to do is to define the characteristics that make the point of sales to success when it comes to selling a product. So for example, if we as a company, we know which works best, that's the information that we need to do to run the analysis. So for example, if we know that if our points of sales are located in business areas, this makes the locations to sell more our product. That's the information that we need to incorporate in the analysis. Apart from this type of business knowledge, we need to include also information about a specific KPI that is able to measure the performance of the different points of sales. That is how much each points of sales is selling our product. So we need to have a KPI that measures performance. That can be, for example, the total amount of sales, the sales volume, or the sales margin. Any KPI that we may think of that represents this sales performance. So in this case, this is the data that we are going to use. This is a subsample data provided by the Data Build company, which is a company that provides points of interest data that is enriched with business and financial information. So what we have is for each points of sales data that characterizes the business. Let me share with you which are the variables that we are going to consider for this analysis. In this case, we're going to include for each point of sales the footfall, which is how busy or how popular the areas are, the sentiment score, which represents how people feel about the locations, whether they really like the place a lot and they would highly recommend it, or if they do not like it, and then the score should be lower. So that's what the sentiment means in this case. We are also going to include the amount of positive opinions that have been found on the internet. And we are also including these two other footfall variables that you can see here. You may be wondering why, apart from the general footfall, we are also including these two. And the thing is that this footfall is specific of a time of the day, which are the early mornings and the early afternoons. And we are including these two because for this specific use case, we are assuming that the peak hours of consumption of our product are during breakfast and just before lunch. So that's why we are including the specific footfall for these two time periods of the day. And apart from these variables, which all of them, as I mentioned, are provided by the data build company, we computed this one variable that we have here that basically represents if our points of sales is close to an area where there is a lot of food service locations. So what we are doing to get this variable here is basically to take for each of the points of sales that we have, we are taking 100-meter buffer around the area and counting the amount of hotels, restaurants, and cafeterias that are within that buffer. And that's the number that we are including here. So all of these variables are the ones that we are going to consider as the business criteria that we want to incorporate in the analysis. And then we have this other variable that is the sales volume, that it's going to be our performance KPI. Just for you to know, in this case, this variable is not a real variable. We've simulated the sales volume in this case. So this is an artificial variable that doesn't correspond to the reality because we didn't have that information. So we simulated it for the use case, so for the purpose of the analysis, so that we can showcase how to work with this. So now that we know which are the information or all the variables that we are going to use, Let's focus on the actual analysis. So, as I mentioned at the beginning, the idea is to create a spatial score in order to identify how well each point of sales is performing. So, what it's important to know here is that when we are creating spatial scores, what we are doing is that we are combining all the information that we have into just one meaningful indicator. So, all these variables that we were seeing here before, the idea is to combine all this information and have only one indicator of performance. This way, we are not only reducing the dimensionality of our problem, but we are also making it more simple and making it easier to interpret. Because right now we have many different variables to work with, but if we have only one variable that contains all the information, we can just visualize that in a map and get insights directly from that unique indicator that we are going to derive. So before going into the actual code to create this, I wanted to explain a bit the internal algorithm just for you to know how are we building this spatial score. And to do this, I've created this graph in here, this architecture graph that explains it. I think it's very easy to follow. So the idea is that, as I mentioned, we are going to consider all these business criteria, all these variables that we've already selected, and also this performance KPI, that is the sales volume. And we are going to feed a regression model with all this information. This way, the regression model, what's going to do is that he's going to understand all the relationships between the data, and it's going to be able to estimate the sales volume based on all this business knowledge that we have. So in this way, what we would end up with would be the estimated sales volume or the expected sales volume. Once we have these expected values, we are able to compare these results with the actual sales volume to see to get like a measure of performance. So in this way, what we are actually doing is to get the residuals of the model that are basically computed by subtracting the estimated sales to the actual sales. And that's what's going to be the final spatial score that we are going to have. To better interpret the results and what the residual means in this case, I've included this graph, this plot in here that I think explains it very, very easily. So that the idea is that all the points of sales that lie within that line or on top of that line are gonna have a residual equal to zero. And this means that the actual sales and the expected sales are going to be the same. So we are these points of sales are performing as expected. But the far away we go from the zero, the less we are, the more difference there are between the expected and the actual values. So, for example, if we found a point of sales with a residual that is much larger than zero, that it's above the line, that means that the actual sales are higher or larger than the estimated values, than the expected values. So we are getting we are over we are getting a better results than the ones that are expected, which means that we are in a point of sales that is showing overperformance. But however, if the point of sales has a residual that is below that line, that is negative and very small, very negative compared to zero, that would mean that the estimated or the expected values are larger than the actual ones, which means that we are selling less than expected, which in turn means that this specific point of sales is showing underperformance. So that's more or less the idea behind the algorithm. So now let me just go to the BigQuery console so that you can see how this procedure is computed. So I have here the code. The idea is just to call this procedure that we've actually recently launched, and it's available in the analytics toolbox for BigQuery. And as you can see, it's very, very simple to run. You only need to include a few inputs, and that's it. So the idea is that you first need to input or select the input data, which are all these business variables that we've previously selected, also this sales volume KPI. And then you need to specify which it's going to be the unique identifier for each of the points of sales, just to keep track of what's going on at each location. Once we have all this specified, we only need to select which is going to be the KPI variable, which is the target variable. And in this case, it's the sales volume, as we've just seen. And we only need to also specify where do we want to save the results. That's going to be the output table. There are also two optional or additional parameters that we can tune in depending on what we want to do. The first one is the R-square threshold. Basically, the R-square is a metric that measures the performance of the model. It measures how good the model is. And what we're doing here is that we are specifying that we want the model to have an R-square of at least 0.7. So if the R square of the model that we train within the procedure is below that value, then we would get an error saying that the model is not good enough, and that we should either change the variables that we want to use for modeling or adapt the threshold so that we can get an acceptable value in this case. So it's kind of like a check, a check to make sure that the model is it's good enough, and we are not just using results that are not statistically significant, so to say. And another optional parameter that we have is this one here, that it's n buckets, that it stands for number of buckets. So basically the idea here is that from the model that we train, we get a continuous variable that is this score. But we want to characterize or categorize this score into different performance groups or performance levels. So that's what we are doing with this parameter here, where we are discretizing the continuous score into three groups that correspond to the locations that are showing overperformance, locations that are showing underperformance, and locations that are performing as expected. Let me explain this, how we do this discretization with this graph that I've prepared in here, which I think it's going to be easier to understand. So the idea is that we have here the histogram of the residuals or the scores, and what we are going to do is to split the histogram into intervals that have equal length. As you can see here, all these breaks or all these uh, buckets have the same length. And one thing that is very important to consider here is that we need to do this discretization centering the results around zero, because as we saw earlier, zero is like our value of reference, because residuals or scores that are close to zero will imply that the performance is as expected, but as we go far away from here from zero, then we are not matching the expectations, either because we are over them or because we are below them. So that's more or less the general idea here. And one important thing to mention here as well is that to compute these breakpoints, these cuts, we are removing the outliers from the calculations. So as you can see, these points here would correspond to outliers, but including them in the calculations would imply that we are distorting a bit the results. So that's why for the calculations we are removing the outliers. But once we have the cuts computed, we will assign the bucket or the performance level to those points that are closer to them. So for example, these points have not been used to compute the breakpoints, but they will have a bucket of high assigned to them because it's closer to this bucket than to this other two. So that's the general idea behind this categorization. So if I just go back to the BigQuery console, we can just take a look at the results of running this procedure, which are stored in this table here. And as you can see, what we have in here are the different points of sales ranked by the spatial score. And we also include here this bucketization that I've just explained. And apart from this is like the main output of the procedure, but we also include an additional table that is this one here that has the same name underscore lookup table that basically explains what I've just shared with you regarding this discretization. So what we have here are these cuts, these green lines that we were seeing in the previous image that are explaining like the range of score values that are within each of the categorization. So for example, if we take a look at this one here, which is the one in the middle, we can see that it goes from -2 to 2, and it has the 0 right in the middle. So this would correspond to the bucket that represents those locations that are performing as expected. So these are the results that we get from running this procedure. And let me share with you how this would look like in a map. So we have a layer here, including the final results. As you can see, these are the same points of sales, but now they are colored by the spatial score. So we can see in pink all those locations that are showing overperformance, and in blue, greenish color, we are seeing all those locations that are showing underperformance. So for example, we can see here, there's a lot of points that perform very good, but for example, in here, we have other points that are not as good. So apart from these insights that we can see directly by taking a look at the map, we've included some widgets here that we think are very useful to filter out the data and get more insights or a better understanding on what's going on with the data. So for example, imagine that you want to take a look at the top 10 performers, those 10 points of sales that are selling above expectations more than any other location. So then we just need to go to this ranking widget and select here that we want to visualize all those locations that have a ranking between 1 and 10. And then it filters out the data, and we can see where exactly are these points of sales. And apart from that, there are other widgets that can be useful. For example, if we want to take a look at all those locations that are showing underperformance, we just click here on the low bucket, and we can see all those locations that are selling less than expected in this case. And we have other filters in case we want to, for example, take a look at the outliers or things like that. So you can play with the filters and try to get more insights from this. And this is everything from the results that we get directly from the procedure. But before finishing, I wanted to mention also a next, like kind of like a next level analysis that we can do with this data that is useful to get or to detect areas for improvement. So how can we do this? What we are going to do is to compare the scores that we got for each of the locations with the average score of all the locations that are in the surroundings in the same area. So that way we can see if some points of sales are performing the same as their neighbors, or if they are outstanding from what the neighbors are doing, basically. And to do this, we are going to work with spatial indexes. For those of you who are not familiar with spatial indexes, they're just a way to discretize the space and divide it into a grid of cells that allows us to perform spatial operations very, very fast and very easily. So let me share this layer with you so that you can see what how the spatial indexes look like. So this is our these are an H3 cells that, as you can see, are dividing up the space and are showing these average values that I've just mentioned. But I wanted to share with you here. I have the query so that you can see how easy it is to get this type of calculations. So basically what we are doing here in this query is that we are taking the spatial score from the resulting table, and we are taking the geometries of each of the points of sales from the input data. And what we are doing is calling this Carto function here that is also available in the analytics toolbox. And we are, from the points, getting the corresponding H3 cell at a specific resolution. If we change the resolution, we would get larger or smaller cells in this case. So now that we have for each point of sales an assigned H3 cell, we just need to group by H3 cell and get the average, in a way that what we are doing is just, for example, if I zoom in here, this cell is basically representing the average of all these values that you can see in here. And one of the insights that we can get from here, as I just mentioned, is recognizing areas of improvement. Let me click on this because I have identified two interesting things that we can take a look at. For example, let's go first to this one. As you can see in here, we have an area in which all the locations seem to be of a poor performance, like they are underperforming or they are performing not so good. But for example, this specific point here is showing a high performance. So one thing that we could do would be to go to these locations and take a closer look at them and analyze them in detail to try to understand why this one is performing so good when the ones that are close to them, are in the same areas, are not performing as good. And we could get insights from this and bring the knowledge to the other businesses to make them boost their sales. And similar, we can find similar things, but in the kind of like in the opposite. For example, here we are seeing an area that shows a very good performance, but we are finding here a location whose performance is not as good. It's actually underperforming. So in the same way as I explained just before, we could go to these locations and try to understand why is this happening in order to increase the performance in this specific location here that is not working so good. So that would be, I think, everything for today. Just before leaving, I wanted to share with you that we have here in the documentation an example that explains this functionality, and we've also published a blog post that explains step by step how to work with this type of analysis and how to work with this specific procedure in the analytics toolbox, that I think it may be useful for you to take a look at. So we will share the links with you. And that's everything on my side. I hope you enjoyed the session and find it useful. And I hope to see you in the next one. So bye bye, and thank you so much for joining.